Hi, we're going to work a little more with vectors today. We will be working in our notes, section 6.1, and we're on number 5, or no, actually 6. We're ready for number 6. But before we start number 6, I want to do just a couple of review problems to make sure that we haven't forgotten what we talked about last time. So a couple of the main ideas. If we have a point P and we have a point Q, and we want to find the coordinates of the vector PQ from P to Q, the coordinates, components of the coordinates or components of the vector, or the directed distance of the vector, is found by simply saying, okay, I'm going from 1 to -3. I look at the x's. 1 to -3, that would be backwards 4, and 4 to 5, that would be up 1. These are the x's, these are the y's. And remember, this is critical. You have to be able to find those. If you want to subtract, that will work. So -3 minus 1, 5 minus 4. But basically, you're describing how you are moving from this point to this point. Then we talked about this means magnitude, and that means length. So the length of the vector is found by basically the Pythagorean Theorem. So we're squaring the first one, squaring the second one, adding them together, and taking the square root. So the square root of 17 is the magnitude or the length of this vector, and this is the notation that means length. And then finally, we said if we wanted to make a unit vector, which is a vector whose length is 1, we would take the coordinates of the original and divide each one by the square root of 17. So this would be the coordinates of the unit vector. So that's a little bit of review. If any of that is confusing to you, go back and watch the last video, which covered the notes 1 through 5. So today we're going to start with the components of vector V, which is number 6. And also, if any of this that I'm erasing right now was confusing to you, remember, you can always come to Flex and get your questions answered. All right, so now we're going to need our calculators. So if you don't have your calculator, pause, run get your calculator because you're going to need it, because we are going to find the components of a vector now, given its picture. So here is the vector shooting up at an angle of 37 degrees, and its magnitude is 16. So this vector is 16 units long, and its angle that it makes with the positive x-axis, and that angle, by the way, is called its direction angle. That's just a vocabulary word in case that comes up later. That's its direction angle. It's made with the positive x-axis. Okay. So this vector has a magnitude of 16 and a direction angle of 37. And we are going to find his components or his coordinates. Now remember, that means we're finding his x and his y. That is easier than you can believe, because we're just going to drop a perpendicular here, make a right triangle, and here's x, guys, right? Isn't that x? And this is y. So here's our x, here's our y. Now, how are we going to find x and y? You got to dig back in your memories, but you all know how to do this. We're going to use Sohcahtoa. You look at this right triangle right here. This is your angle. So y is going to be the opposite side, and x is going to be the adjacent side. 16 is the hypotenuse, of course. So if we're going to find x, we're going to say cosine 37, cosine angle, equals adjacent over hypotenuse. So the cosine of the angle equals the adjacent side over the hypotenuse. So we'll multiply by 16. And that will be our x coordinate. So we'll get our calculator out. You shouldn't have an issue, but you might check the mode. Make sure you're in degrees, just to make sure. And then 16 cosine 37. So we'll round off to the nearest hundredth, so it's 12.78. And then guess what? We still have to find y. And we're going to do exactly the same thing, only now to find the opposite side, we'll use sine 37. So sine angle equals opposite over hypotenuse. Sine angle equals opposite over hypotenuse. So then we'll multiply by 16 and type it in on our calculator. And that's 9.63. Now, I want you to pay attention to how we got these numbers, guys. Notice that to get x, we simply took 16 times the cosine of the angle. And to get y, we took 16, which was the magnitude, the hypotenuse, times the sine of the angle. So I want you to hang on to that thought. We're going to do a couple more examples, and then we're going to make an observation. Okay. All right, so let's look at the next one now. Same exact problem, different picture. This time, this is a 40, and this is a 10. And we want to find the coordinates again, just like before. Okay, so you know what to do. You're going to drop your perpendicular straight down. This is your x, this is your y. And now you're going to use your Sohcahtoa. Look at this triangle right here. This is the triangle you have to look at, right here. So if we want to find x, which is the adjacent side, you can label those adjacent, opposite, and hypotenuse if you want. Remember, opposite is always across. You can say cosine 40 equals adjacent over hypotenuse. So x equals 10 cosine 40, which is 7.66. And then we'll do the same thing for y, only we won't use cosine. We'll use sine because we want the opposite one. So sine 40 equals y over 10. So y equals 10 sine 40. .43. Now, here's where we're going to stop and make an observation. This isn't quite right. This is all right. We didn't make any mistakes. We did everything right. But we didn't pay attention to something really, really important. Are any of you thinking about the location of this triangle being in quadrant 2, and what that means for this side of the triangle? Here's the origin, guys. If we're going this way, 7.66, don't we have to make that 7.66 negative? We do. That 7.66 has to be negative because we are now in quadrant 2. Now, will the 6.43 still be positive? Sure it will, because it's still going up. So y is positive, but x is negative. Remember, you're identifying a point in this quadrant, in the second quadrant. And everything in the second quadrant is negative positive. Now, we didn't worry about it in our first example because we were in this quadrant, and in this quadrant, everything is positive, positive. If we were down here, everything would be negative, and if we were in quadrant 4, x would be positive and y would be negative. So please, 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 pay attention when you're given a picture. Pay attention to which quadrant it is in, because that will determine your x and y signs, the SIGNs, positive or negative. Okay, next problem. We have we have this vector. And again, we're finding our x and our y. Now, in light of what I just said, some of you might be thinking, I'm just going to make them both negative right now. Of course you can do that because you're in quadrant 3, and in quadrant 3, x is negative and y is negative. And remember, that's your strategy. You're finding x and y, and they're both going to be negative when you write your final answer. So it doesn't matter when you put the negatives in, but just make sure that your final answer is a negative, negative. Okay, so here we go. We've got our adjacent side, our opposite side, and our hypotenuse. So if we want to find x, we'll say cosine angle equals adjacent over hypotenuse. So x equals 8 cosine 31. And then we'll say sine 31, that is sine angle, equals opposite over hypotenuse. So 8 sine 31. So I'll type them in on my calculator and see what I get. Hopefully I get the same thing you do. 6.86 for x and 4.12 for y, and those are both negative. So this is my final answer to that problem. They're both negative because I'm in quadrant 3. All right. One more of those. It's 100 units long, and the angle is 15 degrees. And we're going to find x and y. And again, I'm paying close attention. I know that my x is going to be positive, but my y is going to be negative. So I am going to go ahead and make my y negative right now so that I don't forget to do that later. Here's the origin. Positive x, I'm going right. Negative y, I'm going down. Okay, and I want to find x and y. So here we go. Cosine angle equals adjacent over hypotenuse, and sine angle equals opposite over hypotenuse. So I'll type into my calculator 100 cosine 15, and that will be x, and 100 sine 15, that will be y. So I got 96.59 for my x value and negative 25.88 for my y value. Okay. All right, well now we're on to number 7. This is still 6.1. All this is 6.1. Number 7 gives me the coordinates. So now this one's a little bit backwards of what we were just doing. Now I have the coordinates, or the components, and I am going to find the magnitude, which means the length, and the direction angle. Okay? So to do that, I'm going to go ahead and draw a picture of my vector. So I'm going to go over 3, up 2. That's easy. You can do that. There it is. There's my vector. I counted over 3 and up 2. This hypotenuse is the magnitude. Well, you've practiced that already. That's easy. How do we find the magnitude? To find the magnitude, we just use the Pythagorean Theorem. So 3 squared plus 2 squared equals c squared. So the magnitude is going to be the square root of 3 squared plus 2 squared, which is the square root of 13. That's the magnitude. We just do the Pythagorean Theorem. 3 squared plus 2 squared equals hypotenuse squared. We did a lot of that in the last video. Now, this angle right here is the direction angle. I'll call it theta. You can call it whatever you want. But I need to find that angle. Remember a while ago, I told you that the direction angle is the angle you make with the positive x-axis. So this is the direction angle. We're really used to that because before, when we were doing our trigonometry work, we always looked for the angle at the origin, and that's what it is. It's right there at the origin. Now we need to find that angle. I have no idea what it is, but would you agree that its tangent, the tangent of that angle, is 2/3? The tangent of theta is opposite over adjacent, 2/3. Now, boy, I wish we were together so you could show off here. Do you remember how to find theta? What do we have to do differently when the function is attached to the variable? We did it with logarithms. We did it with sines, cosines, tangents. What do we have to do to figure out what angle theta is? How do we type that in on our calculator? If you're thinking second tangent, you are exactly right. This is what you type into your calculator. When it says tan theta, you have to do second tangent. So second tangent 2/3, and that's going to give me the answer, which is 33.69 degrees. So your direction angle is 33.69 degrees. And you're done. There's your magnitude. You got that with the Pythagorean Theorem. And your direction angle, you got that with second tangent. That's pretty easy. Yeah. Let's try another one. All right, so now we're going to do the same thing with our vector as -1, 5. So, well, let me draw more to scale, huh? That's not a very good drawing. -1, 1, 2, 3, 4, 5. So there it is. So using my Pythagorean Theorem, that's 1, that's 5. And I will be able to find my magnitude now quite easily using the Pythagorean Theorem. So what is my magnitude going to be? Remember, to find the magnitude, You just square that one, add them up, and take the square root. So 1 squared is 1, 5 squared is 25. Add them up, you get 26. 1 squared plus 5 squared. There we go. Now, what about our direction angle? Well, here's theta, right there. Isn't it true that the tangent of theta equals 5 over 1? The tangent of that angle right there equals 5 over 1, opposite over adjacent. So how do we see we're going to type that in our calculator? Second tangent. Now, 5 over 1 is just 5, so I'm just going to say 5. But you can do 5 over 1 if you want to. It doesn't matter. So second tangent 5. So I'm going to type that in. And it's 78.69. So this angle right here is 78.69. Now that is not the direction angle though, guys. That is not the direction angle, because the direction angle must be measured from the positive x-axis. This is your direction angle right here. So how in the world are we going to find that out? We know how we got the 78. We did second tangent 5, and that gave us the 78.69. But how now are we going to get the actual direction angle? These two angles add up to 180. They make a straight line. So we're just going to take 180 minus 78.69. And our direction angle is 101.31 degrees. This is your actual direction angle. That is a little tricky, and you're going to have to really be paying attention. But the direction angle is always the angle in standard position. That is, it's starting on the positive x-axis. This is always going to be your direction angle. You're going to use second tangent to find this one for sure. That's fine, absolutely. But then you're going to have to modify, in this case, subtract from 180. But if you're located in other quadrants, which we'll see here in a minute, we won't always be subtracting from 180 to find our direction angle. All right, I know it seems a little bit overwhelming. Be patient, it's not that bad. You can figure it out here. Let's try the next one. -3, -6. Cannot wait to get back to our big board at school. -3, -6. There it is. There's your vector, -3, -6. Now, caution, caution. Make sure when you're drawing your triangles that you're hanging them on the x-axis. Remember your butterfly bow tie. That has not gone away. Every triangle you draw should be one of these. Either that one, that one, that one, or that one. That's your butterfly bow tie. Make sure those are the triangles that you're drawing. So this was 3. This was 6. So we need the magnitude, and we need the direction angle. So to find the magnitude, that's just this right here. That's just the hypotenuse of the triangle. So we're going to do our Pythagorean Theorem. So we've got 3 squared plus 6 squared. We're going to add them together and take the square root. So that's the square root of 9 plus 36, which is the square root of 45, which, I think that breaks down. So break that down. 45 is 3 root 5. So your magnitude is 3 root 5, the square root of 45. 3 squared plus 5 squared, or 3 squared plus 6 squared. Now, direction angle. Let's find this one right here first. Let's find that first, that angle right there. Let's find him. What do we know about him? Well, we know that his tangent is 6 over 3. Opposite over adjacent. Opposite over adjacent. So I can figure out what he is by doing second tangent 6/3 or 2. Certainly you can make that a 2 if you want. Okay? So let's figure out what that is. So second tangent 2. So that angle is 63.43. This angle right here is 63.43. Second tangent 2. Now, that is not your direction angle, because your direction angle has to start here, guys, and go all the way around to here. So just think about that for a minute. You started here, you came all the way to here, which is 180, and then you went 63 more. So this time, to get our direction angle, we're going to take 180 plus 63.43. So 243.43 is your direction angle. Some of you are going to want to try to do the same thing every time when you're finding that direction angle, and you're not going to be able to do that. You have to pay attention to which quadrant you are in. If we are in this quadrant, then just follow my pen around. I have to go this far, which is 180 already, and then I got to go 63 more. So that's how we got 243.43. All right, we got one more of those. 1, -4. And we want the magnitude and the direction angle. So 1, -4. Now remember, I erased my butterfly bow tie up here, but when I draw that triangle, that's 1, that's 4. I draw it like that. Piece of the butterfly bow tie. So the first thing I have to do is find my length or my magnitude. That's my hypotenuse. So I'll do that by saying Pythagorean Theorem. 1 squared plus 4 squared, the square root of that. So 1 squared plus 4 squared, the square root of that. My magnitude is root 17. 1 squared is 1, 4 squared is 16. Add them together and take the square root. That's how you do the Pythagorean Theorem. Now, let's find this angle right here. We always find the angle at the origin. That's the one we're going to find. So we know that that angle has an opposite side of 4 and an adjacent side of 1. So the tangent of that angle equals 4 over 1. To find the angle, then, I have to do second tangent. Anytime that the function is attached to the variable, you have to do second. So we're doing second tangent 4 over 1 or 4. So if I do that on my calculator, second tangent 4, I get 75.96. So this angle right here is 75.96. But that is not the answer to the question. The answer to the question is this angle. You always start on the positive x-axis and come up and around until you get to your angle. So here I am, there's my vector. So I'm going to come all the way around to here. Now I want you to think about this for a second. If you use your logic, use your common sense, if you went all the way around, if I just kept going and went all the way back to where I started, that would be 360 degrees. But I didn't go all the way around. I stopped here. So I stopped before I went the final 75 degrees. So this angle right here, this red, big red angle right here, is 360 minus 75.96. If I had gone all the way around, it would be 360. But I stopped 75 degrees before I got there. So I went 360 minus 75.96. So it's 284.04. That is your direction angle. One thing you can always do to kind of check your work also is make sure that when you write your final answer down, which I just did, 284, make sure it's in the right quadrant. So I got to be in quadrant 4 clearly. My picture's in quadrant 4. So my angle has to be bigger than 270 and less than 360. Because this is 270, that's 360. I got to be somewhere in between, which I am. Perfect. All right. Again, if that's bothering you, you can rewatch this video, or you can certainly come to Flex and practice a few more with me. All right, so now we've got number 8 still. We're moving on to part 8. We're still in 6.1, and we're doing number 8, which says, find the component form of the velocity of a plane flying at a speed of 410 miles an hour on a bearing of 200. Okay, now remember, this is a navigational problem now. We got a plane flying, and when we have that, our setup is different. Our setup is different than all the problems we were just doing. Remember that navigation has its own set of rules. And this is 0. Due north is 0. This is 90. This is 180. And this is 270. So we go this way when we measure navigationally. So when he says he's flying on a course of 200 degrees, that would put him right here. So this angle, this big angle, is 200 degrees. That's in the problem. And his speed is 410. So the length of that vector is 410 degrees. And you are going to find the components, which again, kids, only means find x and y. Don't let the vocabulary confuse you. The components are x and y. That's what you're looking for. Now, at some point, you do need to pay attention to where that vector is. That vector is in quadrant 3 because we went around 200 degrees, and on the compass, this is where 200 degrees is. So we went around that far. Now we're in quadrant 3, which means ultimately both the answers that you come up with are going to have to be made negative. It is so easy to forget that. Please don't. It's going to be negative, negative. Okay. Now, before I can find x and y, and I'm going to use Sohcahtoa, I'm going to use my cosines and sines. But I need to know what this angle is right here. So again, I'm relying on your common sense. I'm relying on you having a fully engaged brain, and you're looking at the situation and saying, okay, from here to here was 200. So what would this have to be? Well, I'm hopeful that you're saying 70, because every quadrant is 90 degrees, and I've gone through 2 whole quadrants, and then an extra 20, because this is 180, so I want an extra 20, which means this would have to be 70. Or 3 quadrants is 270, 3 times 90. But I only went 200, so I have 70 left to go. Somehow you've got to figure out that 70. And now we'll just do our trigonometry. So x is always adjacent, y is always opposite. The hypotenuse is 410. So we'll say cosine 70 equals x over 410. And sine 70 equals y over 410. So it's exactly what we were doing earlier. It's just a different presentation of the problem. But the math is exactly the same. So 410 cosine 70 is my x, and 410 sine 70 is my y. Oh, shoot. I got 140.23 for my x. No, that's, oh yeah, is that right? 410 cosine 70, yeah. And 385.27. And I have marked them already, both negative. It doesn't matter when you mark them negative, just remember to mark them negative. All right, we have one more of those, it looks like, or at least on this page. So we've got our airplane, so we're using our navigational compass headings here, or labels. Bearing of 310, so 310 is going to be out here. This angle is 310 degrees. That big black angle is 310 degrees. And our magnitude is 510 miles an hour. And we are going to find x and y. Before you start, is anything going to be negative? Are either one of these going to be negative this time? Your x is going to be negative because it's left. This is quadrant 2, left and up. So y will stay positive, but x is going to be negative. Okay, so now here comes what's often the tricky part for you. Don't panic. This is so easy. Use your common sense. This is 310. This big black thing I drew here is 310. Your job is to find this angle right here. You need to find this angle right here. Or remember, every quadrant is 90. So 90, 90, 90. So to here would be 270. But you went 310, so wouldn't this have to be 40? Didn't you go 40 degrees past 270? every problem, that angle is going to be calculated differently. So don't try to memorize, oh, I'm going to do this, 270 minus, or 270 plus, or 360 minus. No, don't do that. Figure each one out, because they're all going to be different. Just use your common sense. Count around as you go, 90, 180, 270, and then 40 more. That's how you get 310. So, then we can set up our equations. Cosine 40 equals x over 510, and sine 40 equals y over 510. So 390.68. And 327.82. And I already made the x negative, so I'm done. That's it. Oh no, there's a couple more here in this section. Okay. All right. So a couple more. Here we go. It's a little bit different though. This is a football problem. Throwing the football. Anytime there's motion, there's vectors involved. So you've used vectors your whole life, you just haven't maybe thought about it. But here's the situation. We have a football being thrown at an angle of 53 degrees with the horizontal. And the speed is 12. And we mark the speed as the magnitude. And we're going to find the components of the velocity vector. So components, that means x and y. So this one, there's nothing tricky, there's nothing fancy. Won't x and y both be positive? So I don't even have to worry about negatives here. It's set up, ready to go. No confusion at all. So remember, to find our x and y, we use straight Sohcahtoa. So cosine 53 equals x over 12. X is always adjacent, y is always opposite, because the angle is always at the origin. And then sine 53, sine angle equals y over 12. So we'll go ahead and multiply by 12. And that's going to give us our x and our y. So 12 cosine 53, I got 7.22. And 12 sine 53, 9.58. All right, that's it for that one. I'm hoping I'm not making any mistakes as I'm typing these in. Okay, one more in this section. And that is, here we go. A box is being pushed up an inclined plane as shown. So here, you don't even need to draw your own picture. It's already drawn for you. You don't need to worry about the box and all that stuff. You've got a magnitude of 3 and an angle of 18. And you want to find the component form of the force. So components, remember, anytime it says components, guys, you're talking about x and y. Okay? So here we go. Cosine 18 equals x over 3. Sine 18 equals y over 3. Straight right triangle, Sohcahtoa stuff. Think of an axis here like this, if that helps you. I didn't think about that, but that might help you to have that axis set up like that. So, my components, again, both positive. Both positive. This triangle is drawn in quadrant 1. And if you have a concern about that, remember your butterfly bow tie. They drew the triangle. It wasn't on an axis, but which one of those triangles is this one? Why, it's this one right here, isn't it? That means it's got to be in quadrant 1. Okay, so 3 cosine 18, 3 sine 18. I'm blabbing away. You probably got this done already. 2.85. And 9.93. And that's the answer to the question. Those are the components of that vector. Okay, now we're moving on to 6.2. We're not going to do a whole bunch in this, but we are going to get started in this section. 6.2. So 6.2, we're going to do number 1, which says find v dot u. Now, these are two vectors. See the little vector symbol above them. And this is called the dot product. So when I say this out loud, I say v dot u. That's the dot product. Now it's kind of interesting that in the vector world, the dot and the cross mean different things. This is read v cross u, and it is called the cross product. And they are different things. So we never say v times u, even though we know that is a times symbol. We know that's a times symbol. We never say v times u when we're talking about vectors. We have to say either v dot u or v cross u. Now, today's lesson is about the dot product. So we're going to be focusing entirely on the dot product. So we'll be finding v dot u. So you might want to just make a little note of this, that these symbols mean different things in vectors. In regular math, if I said 2 times 3, you would say 6. If I said 2 times 3, you would say 6. So in regular arithmetic, they mean exactly the same thing. But in vector land, we have to get used to them meaning different things. Okay, so how do we do the dot product? All right, so our first example, you're going to like this. It's really easy. Our first example, this is problem A. We're going to dot 1, -2, and 2, 3. And part of this is going to look super familiar to you. What I want you to do is take 1 times 2. So take x times x. And take -2 times 3. So take the first one times the first one. The second one times the second one. And add them together. So we get 2 plus -6. We get -4. So the dot product is -4. Now, if you think about it, that's a lot like matrix multiplication, where you took the first number of the row times the first number of the column, the second number of the row times the second number of the column, and you added them together. They weren't written sideways. Both of them were sideways. This one was up and down, but the principle is exactly the same. To find the dot product, take first times first, second times second, and add them up. So x times x, y times y, add them up. That's how you find the dot product. It is that easy. All right, let's do our next example, which is -1, 6. V is -1, 6, and U is 3, 1. And we're going to do the dot product. So we take the x times the x, we take the y times the y, and we add them up. So x times x, y times y, add them up. So that dot product is -3 plus 6, so that one is 3. Notice that the dot product is just a number. We started with two vectors, but when we found their dot product, we just end up with a number. This is problem C. 6.2, number 1C. We have 1, 1, and -2, 0. So when we find our dot product, we take x times x, we take y times y, and we add them up. Are you saying, oh, Mrs. Ford, this is so easy, give me a quiz over this? Yes, it is easy. It is very easy. So my dot product came out to be -2. All right, try the last one on your own for just a quick second here. The last one in this section, we have 0, 4 and 7, 6. So go ahead and find the dot product there. See what you come up with on your own. X times x, y times y, add them up. I hope you got 24. 0 plus 24. I hope you got 24 as your answer. Well done. Well done. That's it for today. Have a great day.